Well, good morning, all. I make it 11 o'clock. The clock on the computer makes it 11:04, so one way or another, I think we will get moving. Thanks ever so much for joining this session. This is actually the first session for this new cluster within ESIP, the Open Science Cluster. The title of this session is Building a Thriving Open Science Community. I am Jenny Hewson, and along with Cynthia Hall at the end, we have organized this session along with Charlie Haley, who is hanging out in the back corner, and we are incredibly grateful to Charlie for all of her help in organizing this session. We wanted to quickly review the agenda, but first of all, a few notes about the agenda. We absolutely welcome each of you. We're delighted that you are here. We also recognize that each of you brings a wealth of unique expertise that we are hoping to harness today. We want to hear from each of you. We want this to be fully inclusive of all perspectives. And by participating in this session, we are all adhering to the ESIP community guidelines. Number 2 on the agenda is to provide some context on open science for this session, as well as the goals. This will be followed by a series of panelist lightning talks. After this, we're going to prepare you for the main part of the session, which is an interactive piece, and we'll provide a few minutes for reflection and sharing. 5th is this interactive mind mapping activity that will be led by Charlie. And we are hoping to tease out during that piece some of the emerging trends in open science. Finally, we will have a wrap up and close. A couple of additional notes. This session will be busy, dynamic, interactive, and with that comes the potential for technological quirks. It's also the first session, so we ask for your patience and also that you have fun along with us. There are index cards on the tables. We are hoping that you will write on these, so please, whoever is sitting near the stack, can you pass the stack around the room? And finally, if you are unable to get to the attendance document online, the supporting documents for the session, Cindy has a clipboard with information that we would like you to populate. So in the interest of time, we're going to send that around, and if you can add your information to that, that would be great. Okay, we recognize that open science means many different things to many different stakeholder groups and practitioners. We also recognize that open science is not new. In fact, many communities have been practicing open science for many years for multiple reasons. With that in mind, we do not intend to be overly prescriptive in this session. In fact, we could spend the entire session defining open science. But we do think it's important to provide some context and guidance for this session. So here are 2 definitions of open science. First, the UNESCO definition, adopted in November 2021. An inclusive construct that combines various movements and practices aiming to make multilingual scientific knowledge openly available, accessible, and reusable to everyone, to increase scientific collaborations and the sharing of information for the benefits of science and society, and to open the processes of scientific knowledge, creation, evaluation, and communication to societal actors beyond the traditional scientific community. And secondly, the definition of open science by Ramachandran et al. A collaborative culture enabled by technology that empowers the open sharing of data, information, and knowledge within the scientific community and the wider public to accelerate scientific research and understanding. And I apologize that I'm actually blocking part of that definition. Okay, so again, things to keep in mind for this session. In discussing open science, we are considering a collaborative culture that is open, accessible, inclusive, transparent, and reproducible, that expands participation and partnership beyond the traditional scientific realm, that encompasses the sharing of data, information, knowledge, publications, tools, and frameworks, leading to the acceleration of scientific research and understanding, and in addition, the amplification of new pathways to science. And finally, we have these 4 goals for this session: to showcase these flourishing open science examples through these panelist-driven lightning talks, to identify emerging trends in open science, to really help inform the ESIP Open Science Cluster Work Plan, and also to convey the urgency of embracing open science. And with that, we will move on to our panelist lightning talks. We are incredibly grateful to each of our panelists for participating today, to Matthew Hansen, Abby Benson, Mark Parsons, Cynthia Hall, Kurt Hamill, and Ryan McGranahan. First up, we have Matthew Hansen. Matt is the Geospatial Engineering Lead at Element 84 and has worked with government and commercial and airborne platforms on topics from atmospheric correction to developing machine learning algorithms and exploitation based on his 25 years experience in remote sensing and geospatial software development. An active contributor to multiple open source projects exploiting geospatial and commercial satellite providers, Matthew currently works across multiple projects providing subject matter expertise to NASA's EOSDIS as they move data into the cloud, and science teams from the ERIS Data Center working with Landsat. Matthew is a frequent speaker at conferences on cloud-native geospatial for improving the state of open science. Please help me welcome Matt.
Thank you, Jenny. Thanks for coming to the talk today. So I want to hold on. I think I actually have to look at what I wrote on the slide. Okay, all right. Today I want to focus on the reproducibility piece of the FAIR principles. So it comes as no surprise, I think, to most of you that there is a real reproducibility problem in science. There has been for a long time. And it's even more so with geospatial data. And I think this comes down to the size of the data. This is a lot, it's massive amount of data. And so when somebody publishes a paper and makes that available, and somebody wants to reproduce that, there's a huge amount of work that goes into actually having to download that data and then maybe even recreate the software if it's not open. And it's a real problem. It costs a lot of resources. I think I saw one estimate at one point that maybe as much as half of scientific papers could not be reproduced. And that's actually, I wouldn't be surprised if it was more than that. The trend that we've been seeing over the last several years has been an increase in open data, and this has been great. We see Google Earth Engine has come up. There's a whole lot of open data on there that they've integrated from the different government agencies, from ESA, from NASA, from USGS. The Planetary Computer by Microsoft is a new one, and they are also like making all sorts of data available. The AWS Open Data Program also has made a ton of data available. And this is super great to see. This really does democratize access in one way for users to be able to exploit this data. However, without the software to exploit this, it's really up to individual users to sort of figure it out on their own. And without standards around the search and discovery of that data, it's impossible to find it. And so in order to leverage open data, you really need this open ecosystem of software tooling that everybody can use. And we are seeing that now. Over the last several years, we've seen an increase in the ecosystem around stack and cloud optimized data formats. But even better than open software are open standards. And so I've been involved with the development of something called STAC, Spatial Temporal Asset Catalogs. And with STAC, and also with cloud optimized file formats as a standard, this is more powerful than open software. Because open software, anybody can take software and make it available and give it for free. But open software that's based on standards is even better, because now other libraries can be built. If some library is not maintained, somebody else can take it over. You can build implementations in multiple languages. And this really helps build up, I think, a community of science users, because they have this technology that they can share among everybody in a variety of different languages that they want. Of course, a problem with all of this is training new users in how to access the data, how to use the new tooling, how to search for data using this ecosystem of software. But I think we're getting there. I see more and more training. We see a lot of great tutorials for the Microsoft Planetary Computer for accessing the data, and a lot of efforts around government agencies in trying to bring science users up to speed on how to access this great wealth of data using open software and based on open standards. Thank you.
Thanks very much, Matt. Our second panelist is Avi Benson. Avi is a biologist who has been working with USGS's Science, Analytics and Synthesis program since 2010. She has served as the node manager for the ocean. You made it under time. That was really good.
We never do that.
Right. Avi has been the node manager for the Ocean Biodiversity Information System USA since 2015 and node manager for the Global Biodiversity Information Facility US since 2019. Avi has a strong interest in understanding the patterns of species diversity and how analyses involving data synthesis can expose patterns over broad spatial distributions and longer timescales. Please help me welcome Avi.
All right, I can't really see you all because the computer's in the way. Yeah, I want to talk to you guys today about GBIF and OBIS. So what is the open science need challenge being addressed by this initiative? Well, acceleration and amplification of biodiversity observing through open data sharing and use of standards. And what is really the goal here is trying to understand changes in biodiversity over time. So how is biodiversity changing over time? And we have evidence that right now we're in the 6th mass extinction event that's happening currently, but we don't have the data to really do the analyses we want to do without bringing together lots of disparate species observations data together. And so, GBIF is doing that by bringing 2.2 billion species observations together across 75,000 data sets. And the way that that is happening is through the data standard Darwin Core. So through standards, we can bring data together and then really start to understand changes in diversity, species diversity over time. How has it thrived? Well, it's a global community, and this increasing adoption of the standards is how it's thrived. GBIF and OBIS have been around for 20 years, so they've really built up a lot of trust and a strong global community to go along with these. And then the adoption of the standards and familiarity with the standards that are used have been increasing and creating another sort of global community. The barriers that we encounter are uneven accessibility to participate, language barriers, and cultural barriers. So Amin's talk today really highlighted that uneven accessibility to participate. You know, just because you put the data online doesn't mean that people can use it, that it's accessible to everyone that needs it. And then if you go to a map of GBIF and you look right now, the US, Europe, and Australia are bright red with observations, whereas most of Africa is green, and a lot of Asia is also green. We're missing a lot of observations in those areas. And the ocean is mostly blue. So there's still a lot of work to do. We're getting there, we're bringing it together, but there's language barriers and cultural barriers to sharing that still need to be overcome. So what's the most important trend that I see happening? That's cross-community collaboration. And that happens here at ESIP, so it's really exciting to be talking to you all today about this, because there's things that the biodiversity community can learn from other communities that have already worked through this process. So for instance, parquet files were not something that was known to this community like a year ago. We were all working in CSVs. And now those are there and available. So that's the increase in community collaboration is a trend I'm seeing, and it needs to happen even more. So thank you.
Thanks very much, Abby. And for those of you online, I understand that some of us are taller than others, so I think Matt's head was cut off during his presentation. This works well for me, but obviously we need to move the camera a little bit. So our next panelist is Mark Parsons. Mark is a research scientist and geographer at the University of Alabama in Huntsville, working to help align data, software, and information standards and processes across NASA's science divisions. Mark was the first General Secretary of the Research Data Alliance and has helped coordinate stewardship and a broad range of data from satellite remote sensing to indigenous knowledge of Arctic change. Mark led the data management effort for the International Polar Year and has helped establish the Exchange for Local Observations and Knowledge of the Arctic. Please help me welcome Mark.
Hi, online people. Hello, everybody. So as Jenny mentioned, I helped launch and lead the Research Data Alliance, and so that's what I'm going to be talking about. And the mission of the Research Data Alliance is to build the social and technical bridges that enable the open sharing of data. In other words, they're trying to build infrastructure. And when I think about infrastructure, I think people have a lot of misconceptions of what infrastructure is. It's much more than the pipes, the wires, or the platforms. It really includes the social element as well. It's sort of a socio-technical problem. And in the spirit of Lee Starr, I really see it as a body of relationships, of connections. And so hence that bridge metaphor here in the City of Bridges. And so how did this happen? So RDA started about 10 years ago, and I think it was largely because there was an enthusiasm for this problem, and that led to this open international research data community. And I think that was the biggest thing that came out of RDA, and is still there from RDA, is the community itself. But it did and is still delivering myriad products, everything from the care principles for indigenous data to the detailed specifications of fair digital objects. The pain, if you will, was trying to communicate across many differences, very different national concerns, the way they handle logistics, governance, funding, not to mention the cultures, very different communities. And so there's the different disciplinary communities that think about the world in very different ways. There's different professions, librarians versus computer scientists, as just one example. The funders versus the technicians, so all these different sort of professional communities as well. And then these different communities all have different concepts of what infrastructure is. Even in my sort of general term of a body of relationships, what does that really mean? And many people felt the need that we needed to have an architecture, a roadmap. And that's not actually how infrastructure is built. Infrastructure evolves through a process of building connections. And so that was this challenge, communicating across the difference, this friction, which is actually a good thing. Friction is actually necessary. If you think a metaphor, a wheel goes nowhere without friction on the road. Friction is part of building a community and success. And so the overarching theme on all of this is trust that's embedded in all of this. And Amen hit this way better than I'm ever going to. But it's about building trust at many different scales. And it's important to recognize that trust is not the same thing as reliability. It's more like our willingness to be vulnerable to the actions of others, because we believe that they have good intentions and will behave in a way that we expect them to. And so when or do we need to certify trust, through licensing, encryption, et cetera, and when is it done through the human lens? And at the same time, we need to preserve the freedom to tinker, right? Open source means that you have to allow people to mess with your stuff. And we have to build in decentralization. Decentralization is essential to open science, but it requires trust, right? And any sort of centralization that does emerge has to be community governed. And so how do we build trust? Well, I don't fully know, but I know some things that work. And one is shared community experience. That's how we make friends, right? And so what is this? This is a shared community experience, and we're all happy to be back together again. It's also sharing perspectives, and so enabling a forum for constructive disagreement, that friction again. And then also some level of accountability. And accountability, I think, is most seen in our space through consistent performance, that use your systems, the humans all perform in a consistent, predictable way. And there's this ongoing interplay between social and technical trust. I think the social is largely addressed, like I said, through this shared experience, maybe sometimes through recognized authority. Amen talked about the churches as one example of a recognized authority. And the technical, I think Matt hit this really well, and Abby as well, that the technical is largely done through standards. That's how we assume that something is technically trustworthy. And that act of creating standards, in other words, sort of consistency, works when it's coupled with actual implementation, putting the standard into practice. And that forces you, I think, through this cycle of social trust leading to technical trust and technical trust leading to social trust. And because the act, to develop an equilibrium of conflicting community interests, you have a negotiation between individuals. So this individual up to the community level is also this other constant interplay. And it has to be done in a neutral place and a neutral space. Folks need to feel like they are included. So by neutral place, I mean a neutral territory, a place like ESIP ideally. But it also needs to be a neutral space, an environment that is inclusive, where people feel included and comfortable. And that includes, historically underrepresented people, but also across different disciplines and so forth. So my favorite example is computer science is a field that's overwhelmingly dominated by men, and it was invented by women. So that is not an inclusive environment. And so we have to work on that. And so we have to consciously recognize and work through that friction, and we have to do it at all scales. And then finally, I think as another central piece to this trust that I think came out a lot in the plenaries this morning is data transparency. We're never going to trust machine learning if we don't understand the data that went into it. And so that data transparency is, I think, an essential piece of this as well. So whether trust is a trend or not, I don't know, but it definitely needs to be a trend because it's essential to making open science work. Thanks.
Thank you, Mark. I think building the freedom to tinker needs to be in an open science definition somewhere. Our next panelist is Cynthia Hall. Cindy is currently the community coordinator for NASA's Transformed to Open Science program, promoting NASA's commitment to open source science and NASA's Year of Open Science 2023. Prior to joining, now I'm showing my head. Prior to joining TOPS, Cindy was the community engagement manager for NASA's ESDIS program, developing resources for new NASA data users. She has a master's in geography, specializing in remote sensing and GIS from the University of California in Los Angeles. Please help me welcome Cynthia.
Hi, everyone. Thanks for being here. I'm going to start out with, I think I heard about this book, All We Can Save, Truth, Courage, and Solutions for the Climate Crisis at a previous ESIP meeting through the OpenScapes program. And I just finished reading it a couple months ago, and every chapter in this book resonated with me on some level, and many of which were related to open science. And one chapter in particular, I just want to do a quick quote. Her name's Sherry Mitchell Wayna-Quasit from the Penobscot Nation. She states, "The overall lack of diversity within the patriarchal colonial paradigm has had a suffocating impact on creative intelligence and a divisive impact on society. The more diverse a group or community, the greater the perspectives and innovations that arise and the greater success rate for all." And to me, this is what I wanted to talk about as a component of NASA's new initiative, Transform to Open Science, or TOPS. I think one of the key components of that is to increase participation by historically underrepresented communities. And so to help catalyze this movement toward open science and support changing cultural norms, NASA's championed this TOPS program, and as Jenny mentioned, designated 2023 as the Year of Open Science. And so TOPS is really a global community initiative to spark change and inspire broad open science engagement by focusing on 4 key areas of action. So visibility and engagement, capacity sharing and community resources, incentives, and then changing our value structure, having a paradigm shift. And these areas are designed to increase awareness about open science, provide learning resources and support researchers transitioning to open science, developing open science awards and incentives. And so partnering with other organizations, NASA is going to support and enable the scientific community to move towards open science. And so how has this initiative thrived? Well, I have to mention that one of the reasons we're thriving is because we've got a lot of support from NASA. We're a $40 million 5-year mission across all of NASA's Science Mission Directorate. With the release of NASA's Science Information Policy 41, or SPD 41, it states that all SMD-funded data, software, algorithms, publications have to be made publicly available and have to be developed collaboratively, allowing for engagement from the community. In addition, though, it's not just a top-down approach. We're thriving because we have this great open science community. We have it coming from bottom up. Researchers, many of who are out here from the DACs, the Distributed Active Archive Centers, that are really pushing to be more collaborative. It's become a reality that science needs to be even better, more accurate, and faster to enable this truly transformative breakthroughs that are going to help us thrive. And so working together, sharing knowledges, getting every voice at the table is where we're going to find new and unexpected solutions. And so the community of open science practitioners, many of whom are at our NASA centers, and historically underrepresented groups are advocating for this change. And so what are the growing pains or barriers that I keep seeing come across as we go out and raise awareness of NASA's TOPS mission? Institutional and organizational policies. So open science contributions are not currently recognized when we talk about evaluations or tenure and promotion packages. Competition, most times you have to be a big first author paper to advance, and then you want to build and publish on that to demonstrate you can develop ideas and teams. So there's a strong natural tendency to hold your results close. There's lack of awareness and training, prohibitively high time commitments, lack of incentives, and then lack of inclusive practices, whether that's diversity of skill sets, cultural practices, languages, disciplines, and paradigms. And so the TOPS mission is really trying to look at all of these barriers and see how we can help amplify those that are currently practicing open science and work through some of those. And so what is the top most important trend happening? I chose this one because it's a passion for me, but open science is an ethos behind communities that are intrinsically motivated to contribute to the greater good of humanity. So working openly is a way of building bridges. I didn't realize we were in the city of bridges when I put that in my talk. So there we go. With the larger scientific community, creating more inclusive pathways for those looking to expand beyond their bounds. And this in and of itself serves as a lifeline to many marginalized communities, offering abundant opportunities for growth and development. So the trend that I would like to advocate for here today is really sharing access to hidden knowledge. And that is, I think we'll talk about more about this in the trend section, so I won't go into too much detail, but giving equitable opportunities and resources so that those that have been historically underrepresented have an opportunity to thrive and compete with some institutions that have always had that knowledge. So with that, thank you.
Thank you very much, Cindy. And our next two panelists will be remote presenters due to COVID and schedule. So our next presenter is Kurt Hamill. Kurt is the Senior Account Manager at Esri, providing services to NASA people and programs. During his 11 years at Esri, in addition to supporting NASA, Kurt has supported the US Navy's implementation of ArcGIS in operational systems, including the US Navy's Meteorology and Oceanography Command. Prior to joining Esri, Kurt completed a 28-year career in the US Navy, serving in various operational and technical billets. Kurt holds a master's degree in geographic and cartographic sciences from George Mason University. And Daniel, I believe Kurt should now have access, correct? Kurt, are you with us?
Can you hear me?
Perfect. Thanks ever so much, Kurt. I will chime in when you have about two minutes left, if that's okay.
Great. I've got a timer running too, so I'll do my best to stay on time.
Perfect.
I am sorry. I'm sorry I'm not there. I did want to thank personally Cynthia and Jenny for putting the panel together, all the work that went into this, clearly evident in the good product so far. Yeah, I'm sorry I'm not there in person. Last week was the Esri user conference, and when 15,000 people gather, they bring their germs with them, and I was not good about protecting myself. So let's see. Let me talk from a commercial company perspective. Why would a commercial company be interested in open science? And I think the most basic answer is that people in commercial companies have grandchildren, like many of you do or will have. A successful commercial company holds a long view, not making these the wet film mistake that Kodak made. And the planet matters to everybody. It matters to our grandchildren. Open science guides action. that leaders across industry, governments, and societies should make about planetary stewardship. So as long as there's a pipeline for science that translates into action, I think that is where a commercial company can play its role, because action is what's going to protect our grandkids. Let's see. And what ways have commercial companies benefited from promoting open science? Well, there's been some good examples already talked about today, but Microsoft Planetary Computer, AWS also has Earth on AWS. Esri has the ArcGIS Living Atlas of the World. But the commercial companies, the chief thrust of open science is about increasing access to the insight that science can provide. So as markets and demands for science grows, so do business opportunities. So besides a sense of purpose and duty, there's definitely a commercial interest in open science that can translate into positive quarterly review reports. What barriers do commercial companies face in participating in open science? Well, open science seeks to combat bias, which inhibits discovery and sharing of knowledge, right? So in my 11 years of working with scientists and researchers, I've faced repeatedly misconceptions about commercial software. So I wanted to assert that open science is not synonymous with open source software. Open science is a big umbrella, and open source software has a role to play, as does commercial software. So conflating open source software and open science, I think, excludes commercial software and IT companies from participating with our copious resources in open science initiatives. So indeed, how could any initiative titled with open exclude a community? So that's what I'm saying. So bias against commercial companies is the largest barrier that we face in becoming trusted partners for building and sharing actionable science. Let's see, let me just wrap up with my last one here. What top trend is happening around the advancement of open science? So as Rebecca Nugent at the plenary talked about, shaping the arc of open science is the democratization of science. And UNESCO's definition that Jenny shared, I'd like to focus in on the point about making scientific knowledge available beyond the traditional scientific community. So that's truly the end goal of pressing back the frontier of science, right? That science can guide everyone's decisions, not just other scientists. So the key to democratization of science is about sharing, open sharing. And some companies, whoa, I guess I'm out of time here. Let me close. Some companies, let's see, some companies are moving down the vector to improve science communication. So making science more understandable increases its influence. And the three examples I mentioned earlier communicate analytical results by transforming Earth data into actionable maps, charts, animations, media-rich narratives. So our mission, our market in open science is to share data, share workflows, and share results to a global community. So I wish I were there. If nothing else, it looks like Matt and I would go to dinner together, and I would tell him about how we're building Stack into our commercial product and how we already fielded an open source ArcGIS GeoPortal server that includes Stack as part of its capacity and capability. So anyway, sorry I'm not there. Thank you for hosting.
Thanks ever so much, Kurt. And our final panelist is Ryan McGranahan. Ryan is the principal data scientist and aerospace engineering scientist at Astra Associates in Boulder, where he leads data science and machine learning efforts to improve our understanding of the Earth's space environment. Ryan works across multiple NASA centers and takes a multidisciplinary or anti-disciplinary approach to the study of space, bringing together traditional space physics with innovation from the field of data. Ryan is a passionate science communicator and continually strives to communicate science through compelling storytelling and data visualization.
Hi, Jenny, can you hear me?
I can hear you, Ryan, but the slides will not forward now. Okay, perfect. Ryan, we can hear you and your slide is up. Thank you. And I realize that once you are talking, I'm muted. So if you can try and stay to approximately 4 minutes. Thank you.
Absolutely. So thank you, first of all, to Jenny, Cindy, Charlie. You've done such a phenomenal job organizing this session, and I'm honored to be a part of it and to speak after the set of panelists that you've put together. I've been learning so much just over the past half hour or so. So thank you to everyone who's been speaking so far. So I've been asked to speak about the researcher's perspective on open science. So my comments are going to be refracted through that lens. During the discussion period, I'd be delighted to discuss some other roles, such as unknowing newcomer, willing participant, and facilitator of culture change. But in terms of where I'm coming from with this is I spent a lot of time across numerous different NASA centers, and it was pretty eye-opening to me as I kind of roamed across these and had these fortunate experiences, how disconnected in some ways these efforts in these centers were, even in a situation where your centers are ostensibly very connected, being related through NASA. And so we started to organize some cross-center efforts that were loosely termed around data science. And I realize now that are much more related to open science. How do we connect these different initiatives? And ultimately, the bigger initiative that we're thinking of is how do we connect the sciences that are being done? How do we think about them relationally, and how do we help earth scientists speak with heliophysicists, and planetary scientists work with astrophysicists? And this was kind of the context that we developed an initiative for this. And more specifically, we've been working from within the heliophysics community, because we believe that doing open science requires developing these approach in a kind of ethnographic way within a community, and helping each community define what open science looks like to them, and then helping them be in conversation with other communities so they connect across those. So we've been organizing a Center for Helioanalytics, is what we've been calling it. And really the goal of this is to help the broad heliophysics community do data science and open science in more robust, responsible, and rigorous ways. And so we're outlining a lot of data science and open science approaches through that. And you're going to hear some of what I'll talk about mentioned in different terms. The NSF uses the word convergence research, which I think is very related to this, because it requires human-centered co-creative approaches, which I think are so important with this. And the convergent approach is very much synonymous in many ways with open science. And I know that Jenny mentioned that one of the terms that I like is antidisciplinary, which does not mean against disciplines, but inherently means going to the spaces between disciplines. So how has this initiative thrived? And I'm happy to speak more about it, but just at a high level, it's an ethos. And it starts with systems thinking and healthy relationality, and trying to understand not only how data are connected, but how members of our community are connected, and really centering that aspect of community and focusing on how to build those strong connections. In our Center for Helioanalytics, we have very radically broad connections. And I think if you look at the field of network science, that's actually how networks thrive and begin to flourish, is having these very specific broad connections and letting the community bring that together. This is extraordinarily important for actually doing open science. So it begins with this philosophy, and then it leads to the tools that are required to build these broad connections, and then into the practice, which I'll discuss in just a moment. I think one of the most important things has been an emphasis on knowledge. And you heard Cindy, mention access to hidden knowledge. And one of the ways to do that, one of the starting points, is knowledge representation. So talking with your community about how you're linking the knowledge across different pockets of your community. One of the ways that we're doing that with the Center for Helioanalytics is establishing a knowledge team. This is a team that's dedicated to co-creating the knowledge systems and practices. And the really important point of the knowledge team is that when you talk about something that needs to be living, like open science, there must be a continual conversation about this. You're not going to establish a framework, set that, and let that just go. The knowledge team sustains that continual conversation, and it's been very important to let that evolve and be a living item. Ultimately, it's about building a knowledge commons. And so I put a link there, and I think the definition I put in for open science that I think is one that I operate under, which is open science is transparent and accessible knowledge that is shared and developed through collaborative networks, is illustrative of two pillars of what the knowledge commons addresses and in providing open science. That's intelligent and accessible data infrastructure and the platform to use it. And then also, very importantly, the participatory ecosystem of knowledge sharing, governance, and trust. And so I think that's very important to this. And then it's going from theory to practice. So practices that you develop within a community to define and evolve what open science looks like to them. I have more to say on that, and I'll maybe bring that to the discussion section, but I want to go to what growing pains and barriers we've encountered. So open science for a community is constantly evolving, as I've mentioned, and it requires this continual rethinking and reexamining. Beyond just being time, energy, and resource intensive, which are generally not supported with our traditional scientific research culture, there's also an even more fundamental barrier to this that we need to constantly reexamine, and that's the discomfort and resistance to change. You've heard this mentioned in a number of different ways. Mark, I thought, really eloquently stated how this is related to trust and building trust. But we know that change is unfamiliar and therefore very uncomfortable to many, and it comes with a natural resistance. And so we need to build up that ability to kind of sit with ambiguity and sometimes paradox, as it seems at first. And open science is a way to do that. And so we need to welcome all voices to that conversation and not perpetually strive for immediate resolution. I think that's a very difficult thing, and it comes with a lot of practices that may come from that. So for the final point, what is one of the most important trends happening around the advancement of open science? I think it's this developing a knowledge commons. So it's been mentioned throughout the morning about how important governance is for these and allowing the community to provide governance. I've drawn a lot of inspiration from Eleanor Ostrom and some of the pioneering work that she did in understanding natural resource commons, and then adapting that to our digital resource commons and our community commons and our cultural commons. I think that is such an important trend that we need to be thinking about and making an analogy to. What that implies to me is changing how we gather, changing how we discuss these things. And I think both of these are integral to the point that Mark was making about trust. I think they're kind of silent foundations to trust and kind of give us ways to actually help create that trust in many ways. I'm looking forward to discussing those trends with each of you though. And thank you again, Jenny.
Well, thanks ever so much, Ryan. And I would like to thank each of our panelists again for providing their perspective this morning. We asked the same 4 questions to each of the panelists, and what you got was this rich array based on their expertise. So thank you again to the panelists. We are inviting you, if you have questions, comments, etc., to please provide them on the Open Science Slack channel, to add them to Zoom if you are a remote participant, and also to connect with our panelists outside of the session. And we are now looking to you because we want to pick your expertise. And with that, I would like to invite Charlie to share what we are hoping to do today. And once again.
So you have just, I guess I need to talk to them too, right? I feel very pinned and fixed with this. I usually like to move around a lot. So this is where we need your help. So in talking originally to Cindy and Jenny about, oh, can we go to the next slide too? Do we need to, we need to update that because I think we've been typing in here since we may need to stop sharing the screen and then do update and then share again. Woo-hoo, technology. Oh. Hello. Okay. So when I started talking to Cindy and Jenny about this session and what they wanted to get out of it, this is a new cluster. So they're looking for the community to tell them what direction should the cluster focus on. How do we need to gather and collaborate? What should ESIP as a community work on and focus their time on around open science? So that's why we're focusing on these trends. So you've just heard our speakers. They've given you their unique position on the trends. Like, what are your work and their organizations responding to? It's unique, right? Well, you also are here because you're attracted to open science. You bring a unique perspective to this, right? So you yourself are seeing individual trends, and that if we were able to source those and get them out, now we're going to start spanning the space of what are the open science trends that this community is seeing, and we're going to, from those trends, start forming a mind map with it, right? So this is a total experiment. We're going to be doing an in-person mind map in this room, and we're going to be doing a virtual Jamboard trying to duplicate what's happening in the room. So we're trying to go hybrid here, and it is an experiment, so we will see how well we do with this. Oh, I guess it didn't get updated. Oh, okay. Did you do a refresh? Oh, okay. Yeah, so, okay. So this is where you come into play. You each have index cards on the table, right? So it's like we are working with trends. We're wanting you to capture one trend per index card. So we've got enough people in the room. So think about the top trend that comes to your mind. Let's see. I think there's a slide on, okay, thank you so much, Jenny. So what is a trend? What are we asking for here? First of all, why are we asking you to word it as terms of a trend versus a problem, or something like this is what we need to do, like a solution, right? So by the time you've already identified a problem or you've got the solution, we've got a very narrow focus on what we're going to do. We don't have a lot of room to go, right? A trend is like, this is what we're seeing out there going on. You can imagine if everyone is adding their trend. Now we got a good feel for what's happening out there. Now we can go, oh, that's connected to that. That's connected to that. And now we can say, oh, we've got a better opportunity, a better chance of actually identifying a problem or a solution that spans the space, not just narrowly focuses on something, right? So that's why we're wanting to go to trends. So what is a trend? A trend is anything that expresses movement. I'm seeing an increase, a decrease. We're going from A to B. I'm seeing more of, less than, that kind of thing. So a trend is that way. And it can be in technology, social economics, politics. You can, whatever field you are from your lens, you're seeing. So I'm going to give you like, first of all, in a minute, I'm going to give you like 2 minutes to like kind of write down your trend in this kind of format. So what's the trend? And maybe in parentheses, like an example, like this is a trend I'm seeing, and this is and it's from this area. So write in like example of that, right? So I'm going to give you 2 minutes to do that. Before we do that, do you have how confusing have I been? Or do you understand what I'm asking for? Any questions, clarifying questions? Okay, I'm getting thumbs up that I've been clear enough for you to actually do that. Okay, great. So I'm going to give you like 1.5 minutes, 2 minutes for you to capture your trend on the index card. And then after that, I'm going to put you in pairs or trios to share your trend. So I'll tell you when to stop. Go. Okay. Is this on? Okay. Virtually, we're doing the same thing. So I'm asking virtually for you to capture your trends also. And in a few minutes, you will be put into virtual breakout rooms. And then we will capture your trends either on the Jamboard or through chat and transfer them to the Jamboard.
And a note that the Jamboard is on the screen and is also in the document for today's session online for those who are virtual.
Okay, has everybody had time to capture their trend? Okay. All right, so just to keep this simple for now, because we're going to have movement when we start creating our mind map out back, right? So just form, I think get together in, let's keep this short and simple now. So get together in pairs. Just so turn to someone around you, either beside you or behind you, or if you don't have anyone, you can feel free to go somewhere else in the room. Raise your hand if you don't have a partner. And the option to get in trios is also there, right? So just mainly share what your trend is, right? And what you're hearing, and it helps get it clear in your mind. Go. I'm going to give you like 3 or 4 minutes to do this. Thank you very much. Okay, we're moving to the mind map activity now. And so let's see. So we're going to give you an example of how to do this, and hopefully you'll understand what we're doing. We're going to bring the speakers back to the mind map. So I invite you to turn your chairs around and face the mind map at this point. Okay, keep your index cards close. We're moving to the mind map. I hope, Daniel, you have shared the Jamboard with the virtual participants. Okay, so the way we're going to construct a mind map, and the way that it works is anybody that has a trend to put on the mind map, we'll get to them in the time that we have, right? And you have them on the index card. So what's going to happen is somebody will say their first trend. We'll invite Mark in a minute Matthew, excuse me, to come and say his trend, right? And we'll draw a line. So this is going to look start looking like a root structure a little bit. We'll draw a line. Matthew will write the trend, the scribe will write the trend on here and capture it. And then Abby, will invite Abby to do the same thing. So the question then to Abby will be, okay, where does your trend go relative to Matthew's? Is it like completely kind of opposite? Does it go over here? Is it go kind of close? Or is it actually on the same trend, but just like a branch off of it? So that's going to be the same thing as we start populating this mind map that I'm going to be asking you when you offer up your trend. Where does it go? All trends are valid. It's your perspective on what the trend is and what you're seeing. So all trends, and you just need to know where it goes. So we're going to start, and I'm sure we'll figure this out as we go. Okay, Matthew, tell us again for everyone what your trend is and where you want to start us off on the mind map.
Okay, well, it doesn't matter where we start off, I guess, but yeah, the trend is a vast increase in publicly available data. Which is a positive trend.
Yes, maybe like an up arrow, you know. Okay, and so let's just go right here. Let's draw a line. Perfect. And let's start putting the trends on the line, right? Because after a while, clusters are going to start forming. We'll go, oh, these trends are alike in clusters. And then ideally, maybe we won't have time now, but in the unconference space, we're going to start voting. What cluster do we feel like, or multiple clusters, like resonates with the work that ESIP does? And that's the work that ESIP should pursue, right? Okay, so Abby, come and what's your trend and where does it go relative to?
Yes, of course. The trend I spoke to in my talk is the increasing community or cross-domain collaboration. So an increase in like the Parquet files was my example. And I think that's close to the increase in public data.
So did you say it's a separate one or like on the same trend? Whatever you say is valid.
I think it's a separate one.
Okay, so close. Okay, Cindy?
So my trend is sort of the opposite of what I talked about, in that I talked about the need for trust. Unfortunately, I think that there is a growing distrust in expertise and data. So I guess that is somewhat opposite for what we're seeing here. That, or, you know, in opposition, we have this increase in data. We know more than we've ever known, and people are rejecting facts.
So my trend was an increased access to hidden knowledge, and that being to enable for more inclusion, diversity, and equity. And I think this probably is related to both Mark's and Abby's, because we want to be collaborative, cross-discipline, cross-communities, but it's also going to help with the distrust aspect.
It might be that you draw a line, you go, there's like a dotted line, right? Connecting those to them. This is your mind now. You can make it however you want.
Kurt, did you want to get Kurt? Kurt, are you still online?
Yes, can you hear me?
Yes.
Yes, my trend that I stated was about the commercial mission and market in open science is to share data, share workflows, and share results to a global community to foster action. So I think the three keywords there are share and global and action. So I think in the mind map, there's certainly the, you know, increase the availability of public data, but somewhere in there, is there something about action, making science actionable? The font is really small and I'm having trouble reading.
We were going to put a line off of increase in public data. And so you're suggesting we write a verb.
Promote action, move science to action.
How about you, Ryan?
So I spoke about thinking of this as a knowledge commons, kind of addressing these two pillars, I think, of open science, which are kind of the intelligent infrastructure that everyone has access to. So maybe, you know, an example of that would be the cloud environment, but then it's also the collaborative networks that really need to be present for us to make use of those things and to actually build that trust. And so I think kind of addressing those two pillars in the term that I use is knowledge commons is the trend that I think is important.
Maybe off the cross-domain collaboration, or do you want yours to have a separate?
Yeah, I think that would be a good spot for it.
Okay, so now we are turning to so I'm just going to ask the volunteers, and we're going to pass the mic to you. If your trend is written on an index card, say it out loud so everyone can hear, including virtual participants, and then hand us your index card. So who's got a trend to add?
So related to Mark's, you know, he said decrease in trust, but I think there is more awareness of the need to build that trust across various rights holder groups. So it's maybe a more positive spin on what Mark said, but it is also part of a result of the trend that Mark identified, is that increased awareness that we need to build that trust. So.
And where do you want your trend to go? Right with Mark. Okay. Okay. Sydney, if you got, who's got, okay. Would this be helpful? Okay. Next.
I'm seeing increased availability of high resolution imagery data. So I would put that off of increased public data.
Thank you.
I'm seeing a trend in an increasing realization that successful software frameworks emerge from connecting existing successful community tools. So if we wanted to kind of shorten that up, it might be just like build tools, building on success, something like that, instead of inventing something new.
And where do you want your trend to go?
Well, I suppose we don't really have anything on the tools or framework yet, so maybe off on its own thing.
Okay. Okay, and then I'm noticing that I'm missing hearing, this is an opportunity to meet each other. So when you say your trend before, maybe just kind of say, hey, give us your name before you tell us your trend. I think, okay, who over here had their hand raised? Okay. Who are you?
Hi, I'm Monica Youngman, and I'm with NOAA, the National Centers for Environmental Information. So my trend is off the increase in public data. So I'm seeing an increase in data accessibility. However, I think the flip side is that there's also a trend of less of an emphasis on ensuring the equitable discovery, understanding, and usability of the data. So.
Right. Is it? Give that to Sydney.
Hi, my name is Zhong Liu from NASA JetDisk. I think the technology is basically ready, but the science community is not ready. So my trend is increasing productivity through open science. That's the most attractive, for those who are reluctant to move to open science. We have to demonstrate, those capabilities. So increasing productivity, scientific productivity. I think that trend is probably depends on other trends. Yeah.
After a while, everyone in this room is going to get that all trends are connected. Right? But there will be clusters who identify, hey, this is the problem space.
Yeah, I think the productivity is the selling point, to move them forward.
Okay, I'm going to go over here next. Okay. Oh, you can translate.
Yes. For Kathy Fontaine, she was mentioning that increased awareness of need for ethics training as potentially its own category, maybe. Let's see what she says then. She says, yes, related to most of these, more underpinning in essentially everything.
Well, I think it's a great, excellent trend. Thanks, Kathy. I think, it's somewhat related to this trust issue, but it's much bigger than that. I mean, there's all sorts of ethical issues that we're just now beginning to talk about. Ethical issues with AI, ethical issues with sharing data about marginalized people, also issues with
You, Trent?
I think there's a growing awareness of risks associated with open science that need to get addressed, which cybersecurity risks or national security risks. You want certain science that may help people make more efficient, biological weapons out there for public consumption, or does that need to be reined in, and like cybersecurity risks around like maintenance of open source libraries that maybe after a grant has dried up, who's responsible for taking out, malicious code that was found later. And I just want to point to the awareness of it. There's a Wired article that really opened up these questions that I think really need to be addressed by this community.
Increased risk. Okay, here you go. Do you need that? Or Sarah May. Okay, next. David?
Hi, my name is Dave Fishman. I'm an entrepreneur with NOAA. Off the data trend, more open data, I find there's a trend for IAC, which is infrastructure as code, and PAC, which is platform as code, and then of course software as a code, which has been around for a really long time. This allows us to actually, if we assume that data is all in the cloud with a common URL with in an object store that's not moving, then people can actually reproduce scientific experiments that people wrote papers on because all the infrastructure as code is there, the platform as code is there, software as a service is there, then people can easily reproduce what people have done, and then they can tweak it. And then you don't have to spend a lot of time building up to where that person was, spend their entire career building up to where that person was. They can take from that where that person was and then move on from there. So it creates a great trend.
And you've already told them where? Yeah.
Right off the data.
Okay. Okay.
Hi, Madison Langseth with USGS. So I'm seeing an increasing willingness to provide like higher quality documentation for data that are made publicly accessible. So I think that comes off of the increase in public data.
Thank you. Here. Okay, another virtual.
All right, from Ryan, our speaker, he was saying that trend in the need to mature our conversations around trust, and he put in parentheses from the fact that we need it toward how we actually create it within a community. So I guess more specifics and applicability to developing that trust.
Yeah, can you summarize that for them? So,
applicability to developing trust. Or actually, if Ryan, if you want to unmute and you can state it yourself and summarize it.
Yeah, I think that works well. I just, there's we all recognize a need to create this trust, but how do we actually go about doing that? And in some ways, that's better facilitation, better understanding how we gather meaningfully and communicate with one another. I'm looking at the sticky notes online, which I don't know if those are projected in the room, but to me, there's kind of this super trend here of just better communication that's needed.
okay, who has a trend that you feel like is like really not, like it's a new line, that it's not really, I want to make sure that we're really spanning the space here.
Hi, my name is Katie Deshwak. I'm with NASA Langley Radiation Budget Science Project. I sense, this feels anecdotal, but I sense an increase in concern with the complexity, latency of the software release and export control processes that enable our software to go open source. So I'd say it's near build tools, frameworks, but totally separate off of the future. It's a bit bureaucratic. Latency in the software release process, export control process.
You had one?
Hi, my name is Colette. I'm with UC Berkeley. I was thinking in the realm of indigenous knowledge and trying to understand like the fundamental questions of what is science and who owns it and who defines it, and how that's changing.
The risk of being possibly too obvious, I have an increase in technical YouTube/online talks and seminars for data dissemination. That's starting to become overwhelming, but definitely a trend. My name is Kathy Todd Brown. I'm at the University of Florida.
Yeah, I put it under outreach and training. Okay. Let's go to this side of the room. I haven't heard from you in a while.
Hi, I'm Katie Baines, NASA stuff. And I think there is an increase in the willingness to reward open science practices. So like incentivization, increase in willingness to incentivize open science with, you know, as opposed to historic gauge index incentivization. Oh, I think it's increase in scientific productivity and somewhere over there, but I don't know. I can't really read very well. Maybe it's increased inclusion probably is a better place for it. That pink stuff's real hard to read from here.
Okay, anyone else over here? In the okay.
Mukul Sanwalkar, SSAI, NASA Applied Sciences. I'd say stakeholder engagement is important. The last mile problem, the data is there, everything is there, but how best you push the data to the stakeholders who are in use and can have practical use for the data. Thank you.
And did you say where it goes?
I'd say it would go off of data accessibility, probably usability. Yeah, that would be great.
Okay, I think we've got time for one more, and then we may need to start wrapping up.
Leslie Wyborn, Australian National University. This is more something that to me is a sleeper, and it's becoming a blockage to open science because the funders, it's happening with NSF and in Australia and in the European Union, are demanding data and reporting on who is using all this data on these infrastructures for what, and they require more information than what you can get off IP addresses. And this requires registration or authorization on these infrastructures for access to the data repositories. And it's sort of a competing trend that I'm seeing and being impacted on in work I'm trying to do in Australia on open science. And I know it's happening in the US because IRIS now have, if anyone's here from IRIS, they now have authentication on access to what used to be anything you could get online.
I'm hearing you said it's competing trends. So what are you? So it's like two things you're wanting to put up there, right?
Well, there is the trend towards open science, and I fully support everything everyone has said in the room. But as a person who is also running a repository, and there's a group of us globally working on this issue on how we can get the details that the funders are demanding on who is using what they have invested in, where, what, how, and IP addresses no longer cut the mustard. Right, that's it. It's the increased calling for metrics.
It takes a tribe. Okay.
Look at Wells Fargo.
Okay, we are coming to the close, right? We need to.
We have another 6
Oh,
minutes. Any final?
We have, how much time?
We have 6 minutes total.
Okay, we probably have time for one more. Who has another burning trend? Like, we really need to get this. It's kind of different. Anybody else have another trend to add?
Charlie.
Hi, I'm Terry Velikat from Oak Ridge National Lab, working on some terrestrial ecosystem projects. I'm not sure, there's an increased talk about using AI and machine learning. So I'm trying to figure out how that fits into here. So the future of open science machine learning and AI is going to be using open data. Is that building standards for that? That's building, or trying to figure out where that might fit in there. This is like the application or the use of the open data. It seems to go back to some of the discussion this morning about what's the questions that you're asking of the data that you're putting out there, and then what format it's in.
I think to start wrapping this up, I want to, okay, the scribes, you guys have been writing this. What do you have any comments about what's emerging on the mind map? What are you seeing? What clusters? What's standing out to you from what the group is sharing? Or I invite, what's standing out to you? What's coming to your mind? Any comments about the mind map that's emerging? What insights are you getting? Do we not have enough, Kathy?
So I'm seeing a lot about connections and integrations between people and domains, and that's bringing up that we need to think very carefully about governance and how decisions are made and who's at the table and things along those lines. And that's something that I'd like to see more discussion on.
Thank you. Anyone else? Any more insights? Susan?
I guess I see, and maybe it's just the way that it's laid out, but on the upper left, this increase in everything, right? There's an increase in the public data and all that's on that side, and the opposite side of this distrust in data. And I see, to me, it's kind of pulling apart, right? And how do we bridge that friction or take advantage of that friction, as Mark noted, that with things going so in positive directions so rapidly, the urgency to manage and handle the distrust side of things.
So you can start seeing how with this mind map, some conversations can start emerging, like, oh, maybe in the next cluster meeting, we will figure out, we're gonna start doing a deep dive, like who's interested in this area? Or it's like a way to start organizing the work of ESIP. I am gonna hand things back over to Jenny. Do you want this one, or?
I can use two microphones. Okay, hopefully this will work well. So what's next? We have this great large piece of paper with all of these trends on. We also have this phenomenal Jamboard with all of this information. And so first of all, I would like to say thanks again to our panelists for putting yourselves out there, for answering these 4 questions, for providing your expertise and fodder. So thanks very much for that. Second, I would really like to thank Charlie for choreographing the mind map. Charlie has spent many Zoom calls with me and Cindy, and we're really grateful for that. Thirdly, I want to thank each of you for having no idea what you were getting yourselves into today, for participating, for interacting, for sharing. We really appreciate all of your expertise and are incredibly grateful for what you have contributed. Fourth, we have a question. If we were to propose a follow-up during the unconference on Thursday afternoon, which is from 2 to 3:30, would there be interest in, I think 2 things. I mean, this is just my own opinion now. First of all, to finish off the trends to provide a little bit more time between now and then for you to think about if there are trends that are missing, should be added. And secondly, to give you some dots to put on the map, which I think is this next step to start to kind of rank what are two things. What are the important trends, but more importantly, what is unique to this ESIP community that we could potentially address as the open science cluster, recognizing that Cindy and I are just two voices, and we really need this to be a collaborative community approach to figuring out what is achievable for this cluster. Okay, so I think there were 3 questions there. So if we did propose a session during the unconference, would there be interest in that, in trying to rank and finish up the trends? Okay. Okay, so how would we, do you happen to know, Susan, how we would go about that? So I can, oh, here we go. Look, I'm the holder of both microphones.
Annie's actually our expert on unconference, but how that will work is on Thursday, I believe in the lunch time frame, anyone, either for this specific activity, but anyone can propose an unconference session, and there will be a rapid fire pitch where people come up and basically try and make a compelling pitch to why you should go to their session. We narrow down the sessions if we have more than we can support, and it allows you to then go and continue working on really emerging topics. So what I would say is people should talk to you and Cindy maybe about what might a great open science continuing conversation be in the unconference, and then you guys would propose it on Thursday around that lunchtime, and we'd see if we can make it happen.
Okay, all right, perfect. So we will plan to do that. If you have suggestions, ideas, please do come and talk to me, to Cindy. We are here all week. And let me just minimize these. Okay, and we can see what we should do with this at the rest of the conference. Aside from that, we would really like to encourage you to join the cluster, to talk to us, to email us, to connect with us on Slack. Again, this is a community process, and we are really looking for engagement in that. We suspect there are some trends out there that people didn't provide for the mind mapping, and therefore, if you've written on an index card, please do leave the cards here. Everything that is written on the card is super valuable, and we really want to capture that. So please leave your cards here, and we will collect them. I wanted to say thanks to the remote participants for staying with us, and the Jamboard looks phenomenal, and we will certainly incorporate that into what we've learned today. And finally, we're 4 minutes late for lunch, but thanks ever so much for joining the session today. Thank you.